we will actually now go ahead with the next session, which is a panel discussion with practicing scientists. The topic of the panel discussion is how not to put cart before horse in science. So for this, I welcome our panelists, Professor Prajwal Shastri. She's from Bengaluru, astrophysicist. She's very active in All India People Science Network. Professor Ayan Banerjee, who is from IISER Kolkata. He is a physicist who is also active in March for Science activities around Kolkata. We also have Ayush Gupta, Professor Ayush Gupta from HBCSC, who recently returned from US, and he would give us perspective about how these issues are dealt in US context. The fourth panelist is Professor Anujita Bhadra, again from IISER Kolkata. She is a biologist, behavior biologist, animal behavior, and she is also very active in March for Science activities in Kolkata. So I would request all the four panelists to give initial remarks. Maybe start with Ayan.
Okay, you want me to start?
Yes.
Okay, so great. Yeah, so basically this, this topic that we are kind of encountering, that you've said today, it has two perspectives, I believe, that is. One is, when you say put the cart before the horse, there is a sort of a general tendency of doing that, given the present socio-political situation that exists, in the Indian perspective, certainly, where there is the requirement of getting some credence to some ideas which define or which are in accordance with the, beliefs, I wouldn't say beliefs, but the, the political narrative of a school of thought, or even the party in governance. And this is not something new. I mean, this school of thought existed for a very long time, for like the last probably, almost 100 years. I mean, 1927 was when the first theory was given, for this two-nation theory was given. It was by Savarkar, and then Jinnah took it later from him. But then, the whole thing was that, glorify a certain mythical past. And now that there is a lot of political weight behind this school of thought, the time has probably come for associating that school of thought with credence, as I said, and that requires to get it sort of polished and okayed, by, of course, the West, perhaps, and who better to do that than scientists. So the result is already known. You need to sort of establish something, and you need science as a tool for achieving that. And that is probably the worst way that science can be utilized, where you are required by certain forces, I would say socio-political forces, to put a seal on the narrative that suits them. And of course, this is not something that has happened in this country first. There are multiple examples globally where you would find this happening. In fact, I'm probably tempted to say, the discussions that we had in the previous debate, where we were talking about, I think one of the participants talked about how certain, myths or whatever you say, beliefs have now been shown to have scientific credence. So the question there, of course, comes is to what rigor? Because, see, one very important thing in science is rigor and the scientific method. And here I must say something. I mean, we tend to use the word science in a very loose way. I mean, science is, for me, is an approach. It's a scientific method that really counts. Okay, science is not really a verb. Okay, it is, for me, it is one of the tools, or it is the way things work. It is unraveling that. It is understanding nature. It is understanding, our universe, trying to, make sense of things that happen around us in a way which is described by the scientific method. And that gets compromised in multiple ways. One of the ways is, in a very broad sense, and in a very sort of crude sense, is what I said, where a certain socio-political narrative wants to be, given credence, wants to be put, the seal of, of approval being put. And there is a lot of, worth that you can get by doing this, because, funding, etc., are all decided by these socio-political forces. So if you are not, morally, if you're not strong enough, or if you're not, sort of well inculcated in the scientific method, then you probably are fine with compromising. In fact, there's a very interesting narrative that I hear from many, even of our colleagues, that, you get, suppose there is funding in order to show that ghee or whatever cow, Panchagavya, has fabulous, fantastic properties, and you write a project and you get a lot of funding, and you know that in order to prove this or do some experiments on this, you would only need a pittance of that funding. So you use 10% of the funds for that and use 90% of the funds for your actual project. Now, somebody who is doing this is already compromised, is already gone. He's already put the cart well before the horse, because what he's, he does not even believe the scientific method. They are like completely and absolutely compromised. So that is one aspect. The other aspect is the more sort of, I would say, the more specialized or the more nuanced approach, where in professionals, the practice of professional science itself, you have certain pressures, you have certain prerogatives, again imposed by probably your community in specific, but more general by, again, the socio-political environment that surrounds us, which wants you to behave in a particular way, which gives you the taste of success only if and only you do certain things. That is basically, in our times, you publish in so-called high-impact journals, where if where your success as a scientist is completely and absolutely proportional to the papers that you have in these so-called high-impact journals. And one might probably do well to understand there's a whole concept of impact factor did not exist when I was doing my PhD. And I think many of us who are in this panel, when they were like, in their formative years, this was not existing. This was purely and utterly a commercial motive, started by journals, started by people who wanted to make a business out of science. And now science has got defined by that, which is something that is really unfortunate. I mean, I don't know. Maybe it's too unfortunate, maybe too strong a word, but it's a fact that science is largely driven by that. And in order to do, to be, get what you really call success, in order to achieve success, everybody wants to be successful. There is somebody needs to mute. Somebody needs to mute. I think Rupak Kumar, there is a lot of noise. Yeah. So just to finish what I started, everybody wants to be successful, and now the measure of success is such that you get papers in a certain category of journals, and there is a big nexus also involved there. There are lobbies. I think my next speakers might elaborate on those. But so as a result of which, if you're part of that lobby, I must say, we've suffered a lot, especially the Indian scientists, we see this quite a bit, that if you're not in that lobby, your papers get rejected. Your papers are, get editorial rejections. They're not even sent for review. And the reason is that you're not sort of considered, having long enough arms, or not belonging to that coterie up there. So the reason that I'm talking about this is this whole approach completely lowers the standards, the rigor of evaluation. That this peer review system is not bad. I think it's quite that way when it was envisaged. It's quite good, but it has been compromised now, where attempts to put the cart before the horse are not really addressed or really not really shot down if they are caught. As a result, they propagate. There is this crass commercialization which has happened everywhere. Science is not an exception. There is the societal pressures, globalization, whatever you say. We have some fixed standards. And as per those standards, science as a method of gaining knowledge, that role is diminishing each day, I would say. Yeah, that is what I wanted to start with. I just wanted to define some kind of a perspective.
Thanks, Ayan. Prajwal, would you like to speak next?
Yeah, thanks very much for this. Ayan has laid quite a bit of the ground really well already. And one of the things that really leaps out from what Ayan said, the second thing about what he said, how there is a certain culture being built in science and how that is compromising the scientific method because of commercial interests driving processes within science. That is a global phenomenon, and it's not something that is so obvious, to somebody who enters science, given the way we are trained in science. Sorry.
Nothing. I think so. Somebody was unmuted by accident.
Okay. Okay. Yeah. So that is, and so one would have hoped that this would be the level of the discourse in science today. These are the kind of topics we would like to debate on. What is the impact on science, and how do we counter it, and how do we train and mentor younger generation scientists in order to become aware and so on. Unfortunately, though, because of what Ayan mentioned in the first part of his, what he said, the level of the discourse has dropped really, really low. I mean, we are beginning to debate completely, things that one can't help saying, completely absurd points of debate. So, the reason, I guess, one big part of the reason is what Ayan already said, and one big example is this thing that is called by one of these acronyms that DST always comes up with. I have to look at my notes. It's called Sutra PIC. So Sutra stands for Scientific Utilization Through Research Augmentation, and PIC stands for Prime Products from Indigenous Cows. So this is a program that has been funded by DST, DBT, CSIR, and so on. And it is what Aniket and his team have called putting the cart before the horse. And it sort of gives a lot of legitimacy to things which would normally be just, flying around on the margins in our discourse. And which in the past, at least in my time as a young scientist and so on, we would have said, oh, some fringe people, why should we bother about them? But now it has come into the discourse. And I think we were wrong those days in saying, why should we bother about them? That was part of the problem. So it gives things, legitimacy. We've seen how it has given legitimacy, particularly during the pandemic. You had things like 1 billion people producing metallic sounds in harmony or in unison or whatever, and then people claiming that the virus had receded as demonstrated by NASA data, and all these kinds of things which normally wouldn't certainly not appear in the printed press and things like that. So then we do need to question, and the problem is that the people who are deciding on these programs are us. We it's like our cohort of people who take these decisions and who design these programs and so on. And I would say the climate has gotten so bad that sometimes we talk about cart before the horse, but sometimes there is no horse either. There is just a cart, and there is some delusion or illusion of movement. So by just sort of mixing very sciencey sounding words like magnetic field, electric force, waves, and art nowadays, even artificial intelligence and machine learning and all these, just by mixing all these words, people give legitimacy to some of the things they do, which simply would not pass muster in any kind of scientific framework. And this happens in the media, it happens on TV channels, it happens, even within educational institutions, as we are seeing by the recent master's program that has been approved by IGNOU and so on. And so then, it is really incumbent on us to debate things like this, regardless of how low the level of the debate is. So that this kind of a discussion is very, very legitimate. So if one asks why, I think the part of the problem is the way we have structured our science practice. So naively, one would think, and I certainly thought this as a child when I was aspiring to be a scientist, one would think that if one chooses to be a scientist, one is subscribing to the scientific mode of inquiry, and that meaning that that's not just in the laboratory, but that's our way of thinking, our way of life. However, our structures where we hire scientists and teachers in institutions of higher education and research do not require us to subscribe to this. And there are many examples of this. I mean, I know sort of direct examples where scientists who are employed in the highest prestige institution in the country would still impose these very stringent draconian strictures on their family members, especially women who are pregnant, for example, during an eclipse. And when asked, when confronted, they would say, oh, but that's our job, this is our belief. But mind you, this is not about religious belief, because religious inquiry is about inquiry into the self and our relationship with people around us and society around us, and into questions of why there is hate and jealousy and conflict and stress and all of that, and how do we mitigate all these things. The goal of religious inquiry is not to explain natural phenomena around us, and indeed the best explanation we have of natural phenomena around us is the scientific method, flawed though it may be. So, I mean, it is just unnecessary confusion. It's just causing unnecessary confusion when people mix up so-called religious beliefs with beliefs about everything from an older era. The questions that religious traditions from all over the world have dealt with continue to be relevant today. I mean, I say this as someone who was raised as an atheist and I'm a practicing atheist. I would say that the questions that I listed before are still relevant today. Those are religious questions, and religious faiths all over the world have made their attempts to answer them. But that should not be confused with older beliefs about what is happening around us, and therefore all these outdated unscientific beliefs cannot be justified on the basis that it's somehow religious belief and therefore somehow should not be touched. It's sort of a fragile commodity, because these are things that directly affect people around us. Many examples were cited even in the previous part of today's event. For example, somebody raised the issue about pollution of water bodies, about menstruation in women, and I mean the impact on women. It's quite strong, and it's not just in some remote rural areas. It is even among educated families, educated, middle class, urban, English speaking, all of that families, in fact. So it's not just about some hinterland where this is a problem. So I think we do need to think about restructuring our science practice to foster commitment to the scientific method as a way of life, and to make it an obligation that scientists must engage with the public. Public engagement is not part of a scientist mandate today, whether a university professor or a practicing scientist in a research institution, and I think that is not tenable anymore. It was never tenable, but it is certainly not tenable anymore. We are publicly funded, and therefore we have an obligation to deeply engage with the public. And so this, I would say, these two things are things we need to push for rather vehemently. Thanks.
Thanks, Prajwal. Anindita, would you like to go next?
Yeah, sure. I think I'm going to change gears a bit because both Ayan and Prajwal have been speaking about the public, general policy level issues, and where people are propagating a lot of myths and pseudoscience and beliefs and trying to influence the public with this. I will try to be look a little bit inward into the system and the so-called cohort of scientists and academicians, because in the public discourse today, I think all of us are aware that there's a lot of talk about issues related to scientific ethics, the entire practice of science, the culture of science. And in a way, this is also related to the topic of today of putting the cart before the horse, because when you are facing this so-called competition that Ayan talked about, that, there's this mad rush for publishing in high impact factor journals, something which is a complete business model which has been so nicely adapted by the academic system, simply because people don't want to read through papers and research proposals and spend time on really assessing candidates. They want to add up impact factors and say this candidate has a total impact factor of 50, which is utter nonsense mathematically. You cannot add up impact factors of papers. Papers don't have impact factors. They can have impact, which is not measured through IF. And you cannot add up IF of different papers or journals on a person's CV. It's complete nonsense. And we do this because we are lazy, we don't have time, and we are rushing for the competition. There's this other problem that we have associated somehow quality with quantity. So more is always good, which is not necessarily the case in science. A person publishing a large number of papers does not essentially do excellent science. And also, the more is good has gone into the way perception of funding happens. So if you have received a lot of funding, you must be doing excellent science. And then you keep receiving more funding, and your science is regarded as excellent, whether it is excellent or not. And in this, there are people in our community who can make use of fundings like Sutra Pick and get a lot of funding and do mediocre and less than mediocre science and be graded as excellent, which is a problem for the entire community, and we should be aware of this. Another major issue is of ethics. So let me give you a couple of examples which has nothing to do with scientific ethics, but ethics in general. Yesterday, our daughter, who hates drawing of any kind because she thinks she is bad at it, was given a homework to do some geometry construction. And because of the online mode of teaching, she has no notion how to do constructions because she could not follow the class. She's not interested. So her shortcut was, I will look at the image which has been sent as the example. I'll draw it with a scale, and my brother, who's good in drawing, will put the arcs on top of it, so the homework will be done. Of course, as responsible parents, we had to tell her, no, this is not done. And ethics starts at that level, because for her, it's just a diagram. Construction makes no sense to her. In my school, we had a friend who always got full marks in physics labs because her line of fit was perfect. Until she told us one day that, why do you people bother about, the data points? Just draw a straight line and put the dots on them. It'll be a perfect fit. And of course, now we know that that's not the way you do science. And Unfortunately, though we make our PhD students go through an ethics in science course, I don't know how many of them really understand the difference between putting the dots on the line and drawing the line of best fit. We don't practice the ethics often in our labs. There are students who will tell that the PI told me that this is the expected result and I had to produce the expected result. That is not the method of science. In science, we ask questions, we look for the answers to the questions, and we come up with more questions. We necessarily have a process of testing hypotheses, rejecting hypotheses, or accepting hypotheses. I find it very funny when somebody tells me this is highly significant, and I tell them, okay, how many samples? And they say 3. With 3 data points, people plot mean, standard deviation, put 3 stars over bars, and it's considered excellent data. I mean, excuse me, what nonsense does that? Problem is, how many of our colleagues even understand that 3 is not a good enough sample size to do statistics with? As long as a software can do a t-test and give you a result, it's a result. And somehow we have taken the p-value of 0.05 as sacrosanct, and anything which fits into that is good data, but it's not. Any statistician will tell you that is not the way you do statistics. So ethics have to be taught, have to be inculcated in us. Unfortunately, we are running after impact. We are running after what is fancy science. We are running after what is expensive science, and we are often engaged in finding the correct answer and not finding the answer. And the correct answer is defined by what got published in the most high impact factor journal yesterday. And it does not really have to be good science. It just has to be expensive science. It has to be fancy science. Good journals, so-called good journals, will not accept your paper because you've done rigorous science, but because it sells. And if you go by the commercial value of science, it can no longer remain good science. This is a problem that we don't understand. We just accept that this is the way the world is going and this is the way we should follow. And we just look out to the West, follow what they're doing, and we want the endorsement from high impact journals. We want endorsement from funding agencies. We want endorsement from the administration. We want endorsement from committees, often committees who sit and judge my work without having a single behavioral ecologist in the committee. And I have to explain to them why I run after dogs on the streets instead of writing big grants, asking for a lot of money to buy an equipment which I don't have a use for. So there you decide that if somebody owns an equipment, they're doing good science. That is putting the cart behind the horse? No, before the horse. So yeah, so I think I will stop here and we can go ahead with the questions about this later. Thank you.
Thanks, Anindita. Ayush?
Thank you, Aniket. Yeah, wonderful panelists. Thank you so much. And I feel like part of what we're talking about here is the idea of valuing skepticism, as an inherent part of doing science, right? And the idea that there is a corrective feedback in the sense that there's a way in which the knowledge that we're producing isn't certain, right? Like it can correct itself as we get to learn a little bit more. And I think all of you are talking a little bit about the threats to these two ideals, the threat to skepticism as a value and the threat to corrective feedback as a value. And the threats are, the external sociopolitical threats, for example, right? That make us feel like we already know the answer. I just need to prove it. The answer is no. There are internal sociopolitical threats, right? For example, the rush for impact factors, the pressure to, for grants and all of those things. But there's another kind of internal threat, that is internal threat from disciplinary practice, right? So when we buy into the notion of a particular p-value as automatically telling us what the answer can be in some ways, right? And so I want to build on yet another kind of threat, right? To the skepticism and corrective feedback. And I think it will take us back into the sociopolitical realm, but from the route of deep disciplinary practice. And so I'll start by just sharing a few examples, right? Like we are in this pandemic, we know all of us are in some sense, like that's part of our daily conversation. And so when we think about the science of the pandemic, right? One of the central narratives that is driving this is that we have just assumed that, pathogen causes disease, right? And then the way to solve it is to kill the pathogen, right? And there's nothing wrong with it, but we have put the boundary that that is the only way we will think about it, and there's nothing beyond it, right? And so when we do that, and then we engage in even mathematical modeling of how we can get rid of the pathogen, even when we are thinking about population level models, they have involved this specific narrative, right? This specific narrative of how disease gets eradicated and what is the relationship of disease with the body. What that does is it led to a variety of mathematical models that did not take into account the socio-political realities, the lived realities, let me say, of the people on whom these models will work, right? And so you would find these models where sort of like there's a lockdown and immediately the decline starts, right? As if like you do a lockdown, as if you can do like a chutki bajake, and boom, we are all in our homes, done, right? Just mathematically inaccurate modeling of human behavior, but so much of it drove our response to it worldwide, right? Similarly, in some sense, the virus and the body and all get reduced to the genetics of it. And then we think that we can simply, if we can just fix it by a medicine, right, then we are done. So this is one example, right? Taking a little bit further, let's think about another example where, imagine this, we want to test if the cars are safe or not, right? So people took a lot of data on it. They actually built models of the human body. They put them in cars, they crashed them, it took tons of data. All the p-value stuff was good, good experimental techniques, published in top-notch journals. But what was the problem? All the dummies were modeled after white men. In other words, for decades, cars kept being designed in a way that were unsafe for Caucasian women, for white women, and for the rest of the planet. Basically, they were only safe for white men, right? And so when we think about, thinking about how to make science better, actually just some of the ways in which we think about data acquisition and rigor will not help us move beyond this idea that we need to take into account multiple kinds of bodies when we are doing science, right? So that's another kind of expansion, right? Another example is in order to solve the problem of malaria, people came up with these nets that were infused with insecticide, and they proved that they're not harmful to people. And then they distributed these nets. Of course, the places where these mosquito nets got distributed, if you asked a social scientist, it would be very obvious. They would be like, yes, of course, people are going to use this as fishing nets, right? But the people who are doing the distribution are all technical people. They never thought we can ever talk to social scientists because who are those people, right? And so what happened was, of course, people used them as fishing nets, which led to multiple kinds of problems, including the collapse of fish populations in many of those ecosystems, ecological collapse in some ways, right? Because little baby fish would also get captured in the mosquito nets. They were not designed for fishing. And then the chemical infusions were not designed for safety of fish, but they were tested on the safety of human beings, right? And so what I'm trying to say here is that when we are thinking about what counts as good science, when we are thinking about what counts as ethical science, responsible science, we also have to take into account the threat from reductionism, where we sort of like just imagine the question about does X impact Y, right? And that was part of what the conversation previously was happening, right? So the does X impact Y already takes a reductionist linear model of the system rather than an ecological, complex, adaptive model of that system. And then the technocracy, that technical knowledge is always better than social knowledge. So if we as scientists have come up with something, we don't need to talk to social scientists at all about how human behaves. right? And what that does is, in my work, when I talk to engineering students, my work is on science education. And we talk about the ethics of weaponized drones, for example, that America was using all over the place, right? One of the things we asked was, how can you make this better? And the answer that students had was to make them more accurate. That was the limit of what they could imagine better engineering would be. Right? So our educational system is not pushing us to think beyond this reductionist, technocratic answers to questions of science. And I want to say that if we want to think about ethical science, responsible science, socially responsible science, nope. I want to say if we want to think about better science, then we need to think about the social impact of science, engage those questions. We need to challenge the reductionism and go into complex adaptive modeling of the systems that science is addressing the questions to. We need to challenge the technocracy. And so that's what I want to leave you with. And I want to say that when we march for science, what is the kind of science that we are marching for? And we as scientists deeply, deeply, deeply need to engage with that question.
Thanks, Ayush. At the beginning of your remarks, you touched upon the COVID pandemic and our response to it. So in that context, I would also like to, so we had several case studies there where we jumped to the conclusions first without looking at going through a proper process of science. You told about evaluating the effect of lockdowns. Same is happening. How we are deciding whether some vaccine is going to work or not. Just because it is made in India without any data, we just decide, okay, it is going to work. It is going to be very effective. Then same thing is happening about whether India has reached herd immunity. There was complacency after the first wave. Oh, there is not. So I would like panelists to comment on this lax attitude towards scientific practice, how it has costed us in this pandemic. Anyone?
Let me take that up.
Yeah.
So,
okay, good.
Yeah, we have been trying to engage with the public to some extent. And I think there have been multiple levels. One was definitely policy level lax, or rather intentional propagation of pseudoscientific ideas, where that would have itself affected millions of people, because when the government puts out notifications saying, take arsenic every day and take tulsi and haldi and whatnot, and you will be free of COVID, it's going to grow your immunity, then that itself, endorses pseudoscience. So affects public health, affects scientific temper, and also, pushes back people's work towards public health. So, if you as a scientist try to say that this does not work, please wear your masks, and somebody says, no, but I have banged enough utensils, so I don't need to wear masks, that is a problem. So policy, politicians, government have definitely been a big hindrance towards propagation of scientific ideas and practices during the pandemic among the masses. There have been not enough, or perhaps I should say no, consultation with real scientists to take control of the pandemic, unlike many other countries in the world where scientists were directly involved in fighting the pandemic. Here, all that the government did was come up with new funding to fight COVID. And I know of people who have been given funds to try and, to prove that certain so-called Ayurvedic prescriptions work to cure COVID. So again, putting the cart before the horse, you are not trying to see whether this works. You are given money to prove that neem is going to cure COVID. or haldi is going to cure COVID. So that is doing negative service to science, disservice to science, rather than saying that we have improved funding support for science. Another major way that we are not discussing is there have been push for COVID-related research, but other kinds of research has been affected. How many of us have been impacted by not receiving funds which were supposed to be released? I won a national award. I'm still awaiting the award, which has been declared, which comes with a research fund, and I did not apply for a research grant because I won the award, and the funding never came because the funding agency has no money apparently. So we are pushing for COVID research, which is not essentially scientific research, and research of other kind is being impacted for sure. Students have not had time to do PhD research in the labs because of COVID regulations, and there is no talk about extension of their fellowships for the period that they have lost for the COVID. And that is, again, a policy level decision which has to come through. It is not directly about the pseudoscience, but then science and the quality of science being done in the country and the amount of science being done in the country is going to be affected by the pandemic because of this. And the last point that I would like to highlight in this is that because of this kind of constant propaganda of pseudoscience and unscientific views and endorsement of it by people who are always in the public media. They're on television, they're in the newspapers. Because political rallies have not been stopped, because religious rallies have not been stopped and have been actually endorsed by the government, people did not take the scientists and the medical practitioners seriously. And that has actually helped the peaking of the second wave after a not so severe first wave. So this is why there needed to be much more rigorous scientific discourse and inputs from scientists to the government, and the government needed to have taken the scientists seriously. I don't think even after the second wave disaster, when we have had dead bodies floating in rivers, scientists have been taken seriously enough by the policymakers. And if we don't, do something about it, the second wave is going to have a repeat sometime soon, because we are opening up everything, because we somehow seem to believe that we have reached a state when we can go back to normal and people can stop wearing their masks and stop being cautious, because we have apparently vaccinated enough people and we have reached herd immunity in this country.
Yeah. Okay. Prajwal, yeah, please. I had something, but we can go after you.
Oh, okay. Yeah, so I agree with everything that Anandita just said. I just want to go one level below about the government not consulting scientists and not giving them a voice and so on. I want to go one level below because I think the problem as such is at the feet of the scientists and not with the government. Because I sort of hinted at this earlier, that as scientists, we ourselves don't unequivocally subscribe to the scientific method as scientists, and that is a serious problem. So if I go back to many years ago when the government decided, mind you, there have been government policies. So in 1958, there was this policy that the parliament passed, where there was a very deliberate assertion that the government would fund science in order to cultivate scientific thinking among citizens. It was not about, just some scientific achievements. It was about cultivation of scientific thinking. So there was this idea that they would fund science and that would kind of, permeate, and we would become a scientifically thinking society. Some years ago, when the government mooted this proposition to introduce astrology PhDs in universities, many of us wrote petitions against it and all that, but simply not enough of us, and not the science academies, and not the, I also know of a scientific institution from where scientists signed the petition, but the director of that institution refused to sign the petition. So a lot of the scientists then withdrew their own signature from it because out of fear. So there's all this. So, there has been this thing, and that scientists have seen it as outside of their mandate as to how science is practiced and how science is viewed. For example, when some years ago in Karnataka, in the Karnataka board science textbooks, mind you, not in the history textbooks, but in the science textbooks, they introduced mythology, instances from mythology, which would, which were, what shall I say, which would justify that, ancient Indian science was at the cutting edge and whatnot. So there were examples of, that test tube babies happened in ancient India, and it was justified by using mythology. And this is in a textbook. So there were virtually 3 generations of high school students all over Karnataka who learned this as textbook material. After that, it was not the scientists, it was a civil society organization called the Save India Education Committee, which combed textbooks and then found things like this, and they went to the media, it got printed in the press. Even then, scientists as such were not concerned. I did not see a single position paper from the academy or anything. And we've had these examples time and again. I mean, there was the infamous Indian Science Congress of 2015. There was the claim of plastic surgery in ancient India before that. The scientists simply haven't, made their voice heard. So then, in a sense, it is not surprising that the government, did not see it as essential to consult scientists in the pandemic. So I think that these 2 things are related. So it behoves us to acknowledge that.
I think Bajul's connection broke.
Yeah, I thought mine had broken anyway, so I'm still there.
So Ayan, there is a question for you.
No, yeah, I know, but I just wanted to say something about this, your original question, Aniket, and that is, I think this is important for us to acknowledge that. So this pandemic response is what you asked, right? So that I will just 2-3 things I want to say. Actually, one most important thing, that is, see, the moment you have a running government, not just here, anywhere in the world, which belongs to a particular ideology, that straight away compromises, its attitude towards anything that might be contrary to that ideology. So that we have seen everywhere, I guess. I mean, during the communist period, the Soviet bloc, I think we did have instances of that. That is true. Of course, I mean, no doubt the fascist regimes and all. So here, we actually in India, we did not till now. And I'm going into all this because finally, and that's also answering part of the question that was asked here, that scientists belong to the society. Science, just practicing scientists as we are, and science, scientists as a community, we are nothing but just a microcosm of the world that is around us. We are very much influenced by that. Okay, but anyway, so coming to this, so ideologically, anything which belongs to an ideology, any force, any government, image for them is very important. It is much more important to portray that you are good, you're doing great, you're doing fantastically, you're better than before, which is very crucial. You are better than the ideology that is, that is running now, has given you a country which is, has given you a situation which was certainly better than before, and so you should subscribe to it. So that has been something which has probably made this country suffer immensely, because we were much more interested in portraying to the entire world that we were the world leaders in fighting COVID. We had the lowest number of infections per capita population in the whole world, and the minimum deaths, everything. And that straight away, it just kills any rational approach at first shot, right? And I think that was absolutely reflected in our data. See, I've been doing, a little bit of data analysis. I've not done any kind of predictive modeling, what I liked more was, visualization of data, and because that allows even people who are not specialists, but who are interested in the scientific method, to get an objective idea of what is happening at the moment. And if this continues to be like this, what would happen in the, recent or right in the immediate future? What is going to happen in the next week if the trends are like this? How bad is it going to be? A very short term, this thing, just fitting mostly. But, I was doing it in social media, and people actually, a lot of people were sort of getting idea. I mean, they liked it. I asked many times I should stop, and they said, no, please go on. This is interesting. It's nice. But so when I have handled data, what I've seen is it is just mind-bogglingly inconsistent, remarkably inconsistent. And you can straight see that there is a very, very sort of sustained, collimated effort to somehow disguise quantitatively what you know qualitatively. In fact, one thing that completely, I just do not understand it at all, is when this recent Sero survey says that some 67 or 66 or 68% of Indians have antibodies. That means that amount of population has probably been exposed. So how on earth is our total COVID count some, 1/88, 2% of the whole population is probably, declared as COVID infected? What on earth is this, right? We have 2 crores or something, or some, I'm not, the exact figures don't come to me right now, but I don't think it's more than that. And that is unbelievable, right? And if you're saying that 67%, that is straight about 80 crores, right? Or more than that. How did those antibodies come? Were they magical? And if that is the case, if you have a mortality of 1%, if I say it's even less than that, then can you imagine the number who must have died? Not because of this, or because of related, these other causes? For sure. So that itself, and strangely enough, nobody is questioning this. That is the biggest issue, right? I do not see the media even asking this, what is the meaning of 67% having antibodies when the COVID count that is being given is a paltry, as I said, less than probably 2% of population. What is the meaning of this, right? So anyway, so this is something which I think that is enough, right? You do not need to go into the reasons for dead bodies floating in the river. That's just enough. I mean, somehow we need to portray a situation that is conducive to the way the governance is running, the way that fits the narrative.
Just for the sake of students who are listening to this, so the way to think about it, you can think like this, that suppose if 67% of population has antibodies, so 67% of population had some exposure to COVID so far. And globally, we know that out of every 100 people who contract COVID, 20 people at least show symptoms. So if 67% of the population had contracted COVID over past 1 year or 1.5 years, what percentage of symptomatic cases we should have seen around us? And then compare it with the numbers which we have actually reported.
So I just saw, Aniket, there is 3 crore 19 lakhs exact count at the moment in COVID India website. So that is about 2.5% of the population. Okay, so coming to the next question. See, as I said, we are just a microcosm of the society around us. So it is impossible not to be influenced. But as I said, you have to decide whether you subscribe to the scientific method, not just in the lab, but in your life. For me, when I'm a scientist, I cannot wear a ring which is going to please some divinity somewhere, which is going to take me through the apparent uncertainties of life. I still think that if I want to know something, if I believe that my interpretation is correct, I have to apply that interpretation to something that is probably not known and see what results arrive from there. Prediction. If the predictions are going to be, are going to match with actual events, that rigor I have to have. That has to be like hardwired almost inside me. So, Richard Levantine was a very famous case in point in this, right? I mean, he has this fantastic theories in, the genetics. But there's a big, criticism about him that his interpretations were influenced by his apparently, communist beliefs or something. And so that way, again, there are other people who say that that is not correct, and what he said makes sense. But as I said, if you are in a certain milieu, I mean, another great example that I see is this, the Indus Valley, the Indo-Saraswat civilization, as we now call it, where they Aryans or where they other people, and did Aryans come from outside? That is a tantalizing subject, right? I mean, a certain ideology would absolutely love to propagate that it had to be Indus Valley did not have a script, the Rig Veda had a script, therefore, ooh la la, you just marry those two, therefore the Indus Valley people were Aryans. Great, because that really suits your narrative. The opposite-minded people, and I would sort of probably even confess that I have probably more, sympathy towards that feeling. But anyway, the absolutely opposite-minded feeling would just swear to the opposite. That no, these people came from the central West Asia. They butchered the Harappans, and that is why, the Tamilians are very different from Kashmiris and all. So they are definitely, they're different genetically. And so this is what is correct. Now, of course, there is this genetic evidence which is kind of hinting towards a migration. And that is even that evidence, right? There are people in our own country who sort of supplied the data that I think the person of Archaeological Survey, he claimed the results in a certain way, which the authors in the paper they published, they did not say that, right? So this is where, if you have genetic evidence, see, there is nothing that is absolutely irrefutable in science, as Ayush mentioned, right? There has to be some amount of doubt, there has to be that. But again, that you probably have to say, what is the most probable? And there, you have to somehow try to dissociate yourself from your, apparently socio-political, you are being, your individual, aspect, which probably does not want to go by the scientific method, because the scientific method is not complex. I mean, it is the steps, it is very, very objectively laid out. So if you want to just use that as a that, okay, this. Then there is a matter of interpretation,
Hello. So now.
I got thrown out, and fortunately, I think I'm back. Anyway, okay. So as I was saying, so if we can kind of, check our results and at least get them check a tick box to sort of, with what the scientific method, you probably can reduce the effects of the lack of objectivity. But saying that you would go beyond that, I think it's not a very fair proposition. I don't think it's possible to be, I don't even know what true objectivity means, because we're finally human beings. Our brain is telling us something. So it may be that the brain is probably interpreting it wrong. I mean, is there any absolute at all? I mean, you can come to that deep philosophical thoughts like that. It's all probably a matter of perspective. I mean, things are there because we are there. I mean, there was this massive discussion between Einstein and Tagore, and which sort of went on this thing. But yeah, I mean, this is a perpetual philosophical question finally.
Okay. Thanks. There is a question in chat box for all panelists. So Ayush talked about internal and external socio-political threats to scientific temper. How does the scientific community address these threats? And how events such as this help in that?
Many times they compromise, I can tell you that.
Okay, others, what would they like to say about this?
Prajwal has raised her hand.
Yeah, Prajwal, please.
The short answer is they don't. I think the short answer
is what I said.
We are oblivious. And I think this is more true in educational systems like the Indian one, where if I decide I want to do science, I no longer learn any kind of history or social sciences, humanities, or anything after the age of, in my case, 14 or something. And so there is no rigorous engagement with any of the social sciences and humanities and so on. And on top of that, we are also culturally brought up to be disparaging about the social sciences versus the sciences. It was quite interesting for me to meet some German friend once who said that in Germany the culture is different. In Germany, the scientist is seen as some sort of electrician, and the real thinkers are the people who engage in philosophy. And so it's just not that is, I'm not advocating that, but I mean it's just a different culture. So in our culture, it's like if you're bright, you do science and math. So there is a very clear stratification right from a very young age. And so I think that is a serious problem with our educational system, and also with the way, and when we become practicing scientists, that's just more and more emphasized. So even today, when we are talking so much, for example, about social processes within science, forget about the deep questions that Ayush raised, but even simple questions like why is there a lack of diversity? Why is there discrimination, social discrimination within in higher education, and all these kinds of questions? There is not a ready engagement with all the insights that the social sciences have generated on these questions for decades. I mean, there's so much scholarship there, but there is a very heavy resistance to engage with.
Yeah, Anandita, you were saying something.
Yeah. So, just yesterday there was another panel, March for Science, and I was saying this, that we somehow have inculcated the caste system even in our academics. So there is a very strict caste system. You do science, you do social science. Only recently we have started using the terminology social science. Otherwise, even if you go to CBSE, they don't have social science, they have social studies. Discrimination. In the sciences, you do, theory versus experiment. You do expensive science versus inexpensive science. You do, high-tech science, or you do applied science versus basic science. So there is discrimination, compartmentalization at every point. We don't have dialogues between disciplines, be it among the science disciplines, be it among the natural sciences, social sciences, humanities, arts. I would actually say not just the social sciences. We need to inculcate the spirit of, creative thinking in science. So I would like my students to be creative in their research, not just copy things which have been done in some lab and just do it in another system. And to do that, you need to have creative engagement. So, if you are not a creative person by nature, doesn't matter what you do. Maybe you play the violin, or you do dance, or you make paintings, or you are a fantastic cook, but you have a creative bent of mind, you have a creative streak, you will bring the creativity into the research that you do. Otherwise, you are going to be doing copycat science, which unfortunately most Indian scientists do. That is where, if you are a student of science, immediately from +2 level, you are told you don't have time to waste in extracurricular activities. You have to do this, you have to prepare for IIT, you have to go to special tuitions, you have to only study, study, study. And this entire point, we call them extracurricular. So, and then we expect our, every once in 4 years, we count how many medals we've got. And but then a kid, if a child says, I want to play, instead of doing maths, will not be very happy. So, that is the level of hypocrisy that we have, and that is everywhere. But more talking about programs like this, I think, unfortunately, often what happens is people who think alike attend these programs, participate in these programs, we ask questions of each other, and we feel very happy. But we need to do much more of this. Friends in the media need to write about it. People in, people need to have discussions of this kind on the TV's channels instead of having debates where people just shout each other down and nobody gets to hear anything. Why don't we ever have the debates like this kind on TV channels, which people sit together and watch as families? And again, I think that's where Prajwal already hit the nail on the head, that we scientists haven't tried enough. I often have had colleagues telling me that you are jobless, so you go and do outreach. Don't you have better things to do? Don't you have research papers to write? Why do you waste time going and talking to school kids and going and doing public outreach? But that is, I think, what all of us should do. We are doing our research funded by public money, and it is our first social responsibility to go out, reach out to the public, explain the science that we do. I think if you're a good scientist, you should be able to explain your research to a 10-year-old kid, to your grandmother, to your fish vendor, to your auto rickshaw driver. Otherwise, you're a bad scientist, period. That's how I think science should be done and science should be taught. And that is what we should inculcate in our students. And each of us, if we can at least motivate 5 students to do this in our lifetimes, I think we are going to have a generation with a scientific temper eventually.
Yeah, I want to quickly piggyback on just a short response, which is that, I think the points that are being raised around the division between, science and society, the division between scientists and the knowledge about society, for example, and knowledge production about society, right? The social scientists. This is, addressing Priyanka's question. It's not just that we are not always engaging with these questions, we're actually making it worse. So I'll give you a quick couple examples. You can ask the question, if I take a 10 by 10, 10 feet by 10 feet room, if I increase the ventilation in that room by opening the window, does the level of COVID carrying aerosol in that room decrease? You open the windows and you open 2 windows maybe, right? Like 1 window here, 1 window there. Completely, you can investigate it scientifically. You can try and measure aerosol level in some way, shape or form, right? You can come to an answer to it using the scientific method, right? And it will feel like it's a universal answer, right? Like it's a universal answer because of course, right? What else is there? Where we miss the mark as scientists in asking and answering that question is, what about people who are living in 10 feet by 10 feet rooms where there is now not a window? And now suddenly that question and that answer that seemed universal it becomes a question that is actually bounded by class, by caste, by gender, by social politics, and by the lived realities of people. And when we ask scientific questions that don't actually engage that, but then we try to engage the public on those scientific questions that have nothing to do, that don't realistically capture the lives and lived realities of people, that kind of public engagement can also be harmful. And so what we need to do is also learn as scientists how to ask better questions, right? This is absolutely critical, I think, if we are going to pursue some of this, right? Like we need to question ourselves in that.
One thing I wanted to just add here, Prajwal, give me a minute. So just see this, I think, in fact, Prajwal mentioned this point about, how we stopped about learning other things other from science at a very young age. The reason deemed thereby is that those are unnecessary, right? And that is exactly what you probably will find in this new educational policy as well, where you are asked sort of even. So the attitude is that the great favor is being done by allowing you to strip off subjects when and wherever you want them to, and only focus on one thing that is of deep interest. What this absolutely throws into the dustbin is the holistic, the all-encompassing nature of knowledge. So you have to realize that if you are not a scientist, you're not a professional who lives in isolation. You are not. You are influenced absolutely by the times, by the sociopolitics, by the history of that particular place where you are in, where you live in. So, and especially I can tell you in institutes such as ours, in specialist science institutes, where I find most students that I've encountered at this moment of time have zero opinion about anything that is outside their small, whatever science they are doing. I'm not asking them to be, trade union leaders or go and whatever, burn up a bus or something, but at least have some opinion. There is no opinion, right? No opinion at all. And they are so happy about it. And I remember that, there was a certain incident about, there was that Rohit Vemula thing, which was so big, right? And it's really burned, threw some burning questions at us. And there were a group of students at ISER who probably put up a poster or something like that, who wanted students to come and have a discussion or something of that sort. And they had some posters. And there were, I think, a couple of faculty members who came in, who righteously tore away those posters, absolutely gave them solid, almost hit them probably for what they were doing, and roundly and soundly abused them for violating their mandate. Why are you doing this? This is not a college, it's not a university. Don't do this jandabazi here. And you create complete dumbos who have nothing to do other than go into their labs, do something or whatever, sit in their computers, go do something and then go in their house and do pujas. Because the moment they get out of their labs, they are human beings who are as biased, who are as, completely unaware of the scientific method as the worst ideologist or the worst fascist or whatever is around, right? And another way to sort of see how this happens is that, we are supposed to have some humanities courses, both in the IITs and the ISERs everywhere. And you see how they are dealt with. They are just looked upon as ways of getting a few, relaxing periods, where you just go and sleep or get some grades and get your CGPA somewhat up and just get done with it, man. You don't undo you. And I find this so ridiculous, right? I mean, see, the very, very interesting thing about history, and it is, see, we have this cliche, right? That history repeats itself. If you read a bit of history, you just see it is so true. If you just were aware of what had happened 300 years back or 200 years emerging, you would know what is going to happen. Or a big probability, a very, very large probability of that. But you are not aware. You're surprised. You not see the clouds, the dark clouds gathering, because you're fully unaware. And you do not even realize that knowledge is a holistic thing. And so, so one big thing is that we have to also emphasize that science does not exist in isolation. And methods of knowledge production are not limited by only the scientific method. Humanity has evolved to this level, not just because the technicality that are bound by science, but by a lot of other perceptions, a lot of other storytelling, getting ideas from other people's lives, a lot of things like that. So that is something which we have to realize as scientists, propagate that as well in our institutions, wherever we have the capability, and to students, that history is not something that you mug up dates and forget. That's the worst way of learning history. That is the most, that should be relegated to the dustbin, that type of learning history. Yeah.
Thanks. I think we need to wind up soon. So what I would like to, like all of the panelists to comment upon, and that can be your closing remarks, is you have spoken so far about how scientists are sometimes erring in their duty of doing science in an honest way. But we should also briefly mention about what kind of example it sets for the next generation of scientists, that is the students, and how this culture of not following scientific process or putting a cart before horse affects a training of the of students.
So maybe Prajwal goes first. You had something to say anyway, I guess.
Yeah, I had a couple of things to say about this particular question. I don't think, I mean, what shall I say? It's not, yeah, I mean, some of us may be motivated to do otherwise, meaning motivate to encourage students and mentor students to practice science ethically, to not get compromised, to be aware of science being practiced in a larger system, and so on and so forth. But I think the urgent need is to actually correct our own institutional processes, because otherwise we will land up just continuing to do what we do, which is, like Anandita pointed out very rightly, about how outreach is seen as something something that is done only because you've run out of ideas as to how to write a paper. That needs to go. I mean, regardless of how much we may mentor our students, we are a minority who think this way. The majority of science is being practiced in another way. So we need to push for structural change there. The second thing is that we need to push for structural change where the kind of things that Ayan just spoke about, where, students doing something and their posters being torn up, I mean, that is just simply not on. We do need to make structural changes that allows both students and faculty freedom of expression and expressing that expression, expressing their views, and having study circles and having student government and so on, because that is an important part that needs to be seen as an important part of education. And the third thing was, I wanted to respond to Ayush. I think he raised very, very important points. And I agree that public engagement from the wrong framework is dangerous. But when I said public engagement, I did not mean it as a one-way street. I did not mean it as scientists, we, the brilliant, busy, knowledgeable ones, sort of disseminating things to the so-called common person. I meant real engagement, which is a two-way street, where we see ourselves as accountable. Even at a very, very basic level, I would say after over a decade of outreach, that it is a two-way street, and that, engaging about my research, in which I consider myself as the expert, with a variety of audiences, deepens my own understanding of my area of expertise. But that apart, I think public engagement means being accountable to the public, and if we are coming to it in that framework, we indeed would have to respond to the kind of questions that you have raised, right? And that kind of questioning of our framework and so on would become part of our thinking, and we would get educated as well in different frameworks of thinking, or in seeing the chinks in our own framework. Yeah, but in the meantime, I guess we have no option except to push for these things when we can collectively, and mentor the younger generation that we have communication with in a slightly different way of thinking about science.
Yeah, so one thing that I would like to close with is, I think somehow we need to inculcate in our students that what you finally should derive as when you're in the learning phase, and maybe throughout, is to learn to think. That is for me the ultimate that any course, any subject taught can give you. In fact, I in my whole studentship time, MSc, whatever, all the degrees that you need to do, I never realized that, never ever realized that. I did all my courses in physics, whatever, because they were there. And I had to study, quantum and classical and relativity and all, because they were the requirements of the course. Nobody told me that the reason that you are here is that you are being mentored in a way of thinking that is conducive to something called the scientific, in fact, this phrase called scientific method, I came to know well, I think, you will not believe it, but probably when I was at ISER or something like that, I probably thought of things similar to this. I realized that whatever I was thinking was actually termed as scientific method or something. But for me, it's shameful, right? That I started a career in science without probably having heard the phrase, and I'm confessing here. I do not want to keep this, I might sound like an idiot, but it actually is a fact because nobody told me this. And I probably realized that I learned that there's something called thinking originally, coming up with one's own creative ideas and research, probably the late phase of my PhD. I had a very long PhD, of course, those days in ISC, if you were doing experimental physics, you tended to be a long-termer. I was one of those. And it was only during my ending PhD years that I learned that I could actually I would just forget about what my advisor said and go ahead the way I wanted to. Okay, and then later while teaching, that is also very important. I think scientists need to be told to teach. That is very crucial. Many places in big research institutions, teaching is just giving as, you go to a class, you talk something and get out, because finally you are evaluated for your papers. You get great papers, you get, all the awards are given because you have high impact papers and great projects and great grants and whatever. And you're fellows of this society A, B, C, D, and that is also given to you because you had so many papers in whatever journals. But then the problem is you have zero capability to influence policy, and most importantly, you're not even interested in that. You're not even interested in that because you are working almost like a robot. And probably the reason is that you were never told that education is not doing, solving the problems in Restic and Halliday and whatever, these are physics, sorry. I've learned only that in my life. Whatever textbooks I refer to will only be that. So it is not that. It is not all these things, It is to learn to think. And that is why, in my courses when I have done away with exams. I don't take exams anymore. I take projects. I do, as them to do projects. I take vivas because that allows me to understand what they know. That is probably whether they can think. That is very important. Right? And somehow we need to convince our students that if you want to develop, have power to, have some kind of power to live your independent lives. It doesn't matter if you want to be a scientist. But if you just want to live independently, the one and only thing that you need to learn is how to think. And for that, we somehow need to design our courses, tailor our courses, talk to our administration, somehow convince them as well that the method towards teaching cannot be towards, just giving more and more data. Data can be found by Google. Facts can be just found out from Google. Google will not tell you how to think, how to connect them. Connection has to be done by you, right? So that has to be emphasized. We have to, there is also another thing that I've seen. We say all these things, but we do not want to take the time to influence them at policy level. We do not want to go there in administration. Administration is dirty. It is complete waste of time. But at the same time, if everybody who is good, who actually wants to apply change, runs away from the real responsibility, that will not work. So we have to, get our students to do quantitative, propagation of science as well. Invest in societies. We have a light society in our institute where these people go out and talk to schools in it's situated in almost rural Bengal. That is one advantage. They go to small village schools and all and demonstrate lasers and all kinds of things. And you just clap them on their backs and say, well done, very good. It doesn't matter if you have 3 papers. I'm very happy that you can explain your last paper in Bengali to students of class 8. Actually revel in that, make them proud of that. And please, please, please make them understand that quantum mechanics 1, 2, 3, you will forget if you are not going to dwell on that in your research. But that ability to rationally analyze, to solve problems, to think, if you get that, that is what teaching can ever take you, constructively.
There is one very quick thing I wanted to respond to. Can I just do that, Aniket?
Yes. Yeah, sure.
So Ayan talked about assessment. I just wanted to respond there that I have heard this practiced also maybe in Madurai Kamaraj University or somewhere like that, that the way the assessment would be done is to assess whether the student shifted as a result of a course. So assess where the student is before the course and then where the student is after the course, and assess whether they shifted. So not try and assess whether they can solve X kind of equation or whatever. So I just wanted to put that in there because I thought that was a very interesting way of looking at how we structure our education.
Other panelists, would you like to give any closing remarks?
Yeah, I have a couple of things, but Anindita,
yeah,
please.
Go ahead, Aish. No, Aish, go ahead. I'll finish later.
Okay, sure. I just want to say, yeah, we need structural change, and that structural change needs to take into account fostering transdisciplinary practices, right? Like we have to break out of our disciplines. And I don't mean like physicists collaborating with biologists, right? I mean far beyond that, you know, like imagine physicists collaborating with, you know, people who do critical discourse, people who do,
history, Ayush, history.
Contemporary literature, right? Like I'm saying, all kinds of fostering collaborations. It needs to, you know, just, you know, really challenge the social technical divide. And it needs to, like Prajwal was mentioning, imagine public outreach in a way that it is really a two-way street where we are learning from each other rather than teaching the other, if you will. And of course, like we want to help our students learn doing that. But I want us as a community of scientists, not just the 4 or 5 people here, the 4 or 5 talking heads that we are here assembled, right? But as a community of scientists, I want us to challenge us to rethink the assumption that we know how to do it. Let us tell our students how to do it. I want to say, we need to learn, we the experts, we the professors, we the scientists, we actually need to learn how to challenge these assumptions in our thinking, in conceptualizing our research projects, in conceptualizing our courses. And so structural transformation of the institutions that we are part of will need to invest in the learning of the professors themselves and not just in the learning of the students. And it will need to give the space to do that, to make mistakes while doing that, to take chances and risks while doing that, so that us, our students, and all of the people who are surrounding our institute together, we might be able to imagine a better world, a better society.
Okay, I just wanted to add on to everything that all of you have said. I thought I'll end on a more positive note because we've been doing a lot of cribs throughout the session and identifying problems. So talking about breaking silos and working among disciplines, I belong to this organization called the Global Young Academy, where we try to do a lot of interesting stuff. So one of the things that a friend of mine started there, which was very successful, we call it Art for Peace and Justice. Art and Science for Peace and Justice. So what they do, so he was a very creative person. He created music out of neuronal signals. He created music out of DNA codes. And he was using these to tell people, especially young students, of how you can have fun with science, and how science is not just boring stuff which you mug up in textbooks. So there are ways in which we can engage across disciplines, and this was done in collaboration with musicians and scientists. So there is a project which is going on where we are trying to use art to tell people about climate change and use this to, kind of propagate this among school children, where we have a language barrier to, because it's a global young academy, we go to different countries, we don't speak the language. We use art as a mechanism where you can dance a topic, or you can make a painting, or, do a mime and explain the problems about loss of biodiversity or climate change. So that is where you can bring together people from different disciplines to think about a global problem and communicate to people at a level where, they can engage, not just listen, but we do this with school kids who come and engage in this discourse. So that's one way of engaging. I can tell you that, yeah, I'm definitely one person who is I love teaching, and what I do in the first class is I tell my students when I teach them evolution that you will ask questions and I don't have answers, so we will together try to find the answer. And I remember one class I told them, okay, so I kind of told them what the syllabus is and how grading is going to be done, blah blah blah. So I said, next class we start and you have to come up with any question about life which begins with why. And the class will start. And when I went to the class next time and said, okay, questions, and I got 150 blank faces. And I tried to coax questions out of them. Nothing came. After 5 minutes, I said, okay, fine, I can't teach. I don't have anything, so I'm leaving. And I started leaving. And then somebody said, ma'am. And then it started. And then the class refused to end. Finally, a student came up and told me, we didn't really trust you when you said we should ask questions, because nobody has ever told us to ask questions in class. How can a teacher ask us to ask questions? And that's what I do. This time, the first assignment in my first year biology course was ask a question. That was the assignment. They had to come up, look around, find a living creature inside their homes. It's the pandemic, online teaching. Ask a question. And there were fascinating questions, starting from lizards, cockroaches. Those were the two favorites. Mosquitoes, birds, plants. So we can engage. One of the assignments that we had was if you went to Galapagos Islands and you suddenly started hearing voices and you realize it's the finches who are talking. And they're cribbing about this guy called Charles Darwin who came and ruined their lives because he was always spying on them. And you have to write a dialogue or a story about this. You know, the entire thing, that was an assignment. They first told me, you really want us to write a story? It's a biology class. I said, yeah, I want you to write a story. And you will not find it on Google. And one of the best things about this is they say, we love your assignments. And no, what else can you get as good feedback for a course after this? If you make them think, if you make them imagine, and they actually like it. So again, I don't know whether at least they don't know whether I was teaching them biology or English or creative writing, but it was fun. So I just wanted to end on that yeah, there are ways in which we can inculcate ideas in students, and we don't have to teach them to do it or tell them to do it, but we have to live by our own examples, and hopefully some of them will follow. Thank you.
Thank you all the panelists for excellent discussion. With that, we conclude our panel discussion.